Hey folks, today we're jumping over to Inscribed Angles. I know it says 8.5 where you actually skipped 8.4. I hope you don't mind. Oops, sorry about that. But I think you'll get over it, I hope. Okay. Anyways, let's go ahead and move on. So just like a little recap, I know I mentioned this before. I just want to make sure we understand these shapes and how to sort of describe them and talk about them. In this case, we've got a triangle inside of a circle, and so formally speaking, we would say that we have a triangle inscribed in a circle. Okay, scribe, I guess, is means like written or drawn or something like that, and then in, I think you know what in means, and then the circle is, in this case, in this diagram, is circumscribed. I didn't leave a lot of space here, but circumscribed around or about a triangle. Okay, so again, the circum means around, scribe, that's that writing thing again. So the circle is circumscribed about it, about the triangle. And then over here, it's kind of flipped. So here, the triangle is circumscribed, even less room I gave myself, circumscribed about a circle. And, or in other words, another way to describe it is that a circle is inscribed in a triangle, okay? And things to emphasize here, these are tangents. So there's points of tangency here. The vertices lie perfectly on the circle. And so now we're going to talk about inscribed angles. So I just wanted to have that sort of a context because now we've got an angle that's inscribed inside of a circle, just like in this little picture over here. So we've got this angle, I guess you can call it angle B, and then it's basically made up of two chords, just segments inside of a circle, right? And here's the B, and then this right here we call the inscribed angle. So that's what that is. That's the inscribed angle, okay? And then these chords go out and they intercept, if you will, this arc, right? So that's the intercepted arc. That's what this is out here. Again, the intercepted arc. If you think about, like in football, you have an interception. That's when the ball is flying through the air. The defender cuts in front. Okay, this analogy is not going very well, but you know what I'm saying. So what's the relationship here between this angle and the intercepted arc? Well, we won't prove it here, and the proof takes a whole bunch of steps. So I'm just gonna let you know. This angle is going to be 1/2 the measure of its intercepted arc. So here in this diagram, we would say measure of angle B is 1/2 the measure of arc AC, the intercepted arc. All right, good. So let's scroll down, and by scroll I mean let me slide this paper up, and let's look at this diagram. They want us to find A and B, so let's first look at A. A is basically the degree measure of this arc, right? And that's arc PT. So that's what we're looking at. That's arc PT. And if you look at it, what's the inscribed angle that corresponds with arc PT? Well, let's follow these chords back, and they come back to this angle right here. And that's angle PQT. So measure of angle PQT. What's the relationship between this angle and this arc? It is 1/2. So measure of angle PQT is 1/2 of arc PT. Okay, so what does that mean? Well, we know angle PQT is 60 degrees, and measure of arc PT, well, that's A, right? So what's A? Hopefully you can catch on to this. I know you can. It's just 120, right? It's just like you multiply both sides of this equation by 2. 2 times that, cancels 2 times 60, you get 120. All right, now let's go on to B. That's what they want us to find next. B is over here. What does this angle intercept? Well, let's kind of follow it out. Let me use a different color. So this chord and this chord, that's a bigger arc. That's like this over here. And what is that made up of? Well, we just found out that arc PT is 120 degrees. And then this little baby arc down here is 30 degrees. So let's think about that some. So measure of angle. Am I saying angle? Yeah, I'm saying angle. Measure of angle PRS. That's going to be equal to 1/2 the measure of arc PS, right? And arc PS is made up of 120 plus 30, those two arcs right there, right? And this is just angle B, or yeah. And so what's 1/2 of that? 120 plus 1 plus 30 is 150. Half of 150 is 75. Okay. Oh, sorry about that. Scroll up. All right, hopefully that wasn't too bad. Okay, I'm gonna slide this out of the way and start off on the next page up here. So let's look at this. So now we've got corollaries to Theorem 86. This was Theorem 86, the inscribed angle theorem, and these are corollaries. Corollaries are just like little side mini theorems that directly follow from a sort of a bigger theorem, and they can be easily proven from it. But so let's kind of sketch the situation in each corollary. So corollary 1, 2 inscribed angles that intercept the same arc are congruent. So let's draw 2 inscribed angles. Let's go with the first one we'll do is I don't know, have it look something like this. Go and grab your ruler if you don't have one, or some kind of straight edge. So there's one arc, right? There's one inscribed angle, excuse me. And then out here is the intercepted arc. Now let's draw another inscribed angle over here. Let's call that B. That point is B. And then let's draw it out so that it intercepts, just like that defensive back intercepting the throw for the, okay, forget it. So it intercepts the same arc. Look at that. So that means both of these angles, since both of these angles intercept the same arc, those angles are going to be congruent. All right, corollary 2, an angle inscribed in a semicircle is a right angle. So let's go ahead and draw a semicircle, or really what we're going to do is just sketch a little diameter. And we've got a semicircle here, right? Just by drawing a diameter, this is the semicircle. I think we know something about that semicircle. And so if we have an angle that intercepts the semicircle, boom, and boom. How about that angle right there? This angle is intercepting a semicircle, so that means this angle is going to be a right angle. Yeah, that's pretty exciting, right? Because this is 180 out here, and so this is going to be 1/2 of the 180, so it's going to be 90. A right angle. And there's another theorem, I can't remember if we're going to do it next section, maybe not. But that says if you have a triangle inscribed in a circle and one side of the triangle is a diameter, then guess what kind of triangle you have? Yep, right triangle. Okay, the last one, we've got a quadrilateral inscribed in a circle. So let's do that. And I'm going to try to draw just a random quadrilateral, not any special one, like not a rectangle or a trapezoid or anything special like that, just a nondescript quadrilateral. I don't know if I can do that. I feel like I always try not to, but let's see. Whatever. Yeah, that feels trapezoidy, but I didn't mean for it to be just a random quadrilateral. Let's call that A, B, C, and D. So if you look at this, let's focus on first, let's go with angle A. Let's look at angle A. And let's look at the arc that angle A intercepts. So out here, and then out here. So it intercepts this arc right here. Arc BCD. Right? And then let's look at, we're talking about opposite angles. Opposite of angle A is angle C. So angle C, what does it intercept? It intercepts this arc out here. What do you notice? Look at the red arc and the blue arc together. The red arc plus the blue arc, what do you think that equals? Well, it's a measure of arc DAB, plus measure of arc DCB. Oh, I wanted to do that in blue just to have matching colors. Wait, you know what I did? Did I do it right? Yeah, I think I did it right. And then measure of arc DCB, red, blue, equals what? It's a whole circle, so it's 360 degrees. Well, similarly, if we look at the angles, so measure of angle A plus measure of angle C, what did they equal? Well, these are just half of that total, so that's going to be 180 degrees. So A and C, these opposite angles, are supplementary, and similarly D and B are supplementary. Ooh, that's pretty cool, huh? Yeah, I think so too. Okay, I'll catch up with you in the next video.